Okay, well here's the first attempt at the first lesson. Hopefully this goes well. I haven't done this before. We'll work out any bugs as far as being too loud or too quiet. It's going to go from here. Um, First topic, looking at finding limits graphically and numerically. So we're going to estimate a limit using numerical and graphical approach. And then we'll also learn ways a limit can fail to exist. At any time you need to, just pause this so you can write, catch up, and you can play it again, or you can back up if you need to, anytime. Okay, so the limit. This is one of three basic topics that we look at in AP Calculus, certainly in Calculus 1 and throughout Calculus. The limit is kind of a pre-calculus topic, but we cover it in Calculus. And there's a formal definition, which I'm not going to get into. If you want to, you can find it in your book. But informally, it's basically, at its most basic point, it's the expected value, or the y value, for any given x value of a function. The limit of a function is the expected value, or the y value, at a given function, at an x value in a function. So we have some function, x equals 3. We want to know what would we expect the y value to be at 3 for that function. Okay? So, in the past, we would just plug in that value, x equals 3, into the function. Whatever we get for our value, that would be what we would expect. But there's times when that value might not exist. So let's take a look at an example here. So for this example here, f of x, here's a function, f of x equals x squared minus 4 over x minus 2. Okay, now, if you wanted to look at the graph of this, well, we could graph it. Let's put our calculator here. Turn it on. What's going on? Hold on now. Okay, there we go. Sorry. So, if I wanted to graph this, I'd go over here to y equals. Since I have a numerator here, I want to make sure this whole numerator is in parentheses, so I get the whole thing up there. So I have x squared minus 4 in my parentheses for the numerator divided by the denominator in parentheses. Very important when you have a binomial in a fraction like this. Okay, if I want to look at the graph of that, I'm only looking at part of it here. So I'm going to go to Zoom 6 is the standard menu. Zoom 6 is right here, standard.
May I have your attention, please? At this time, for my whole.
All right, sorry for that interruption. Okay, so there's our graph. X squared minus 4 over x minus 2 looks like that. Looks to be a solid line. We have a slope of 1 and an x-intercept at -2 and a y-intercept at +2. But if we go to the table now, if we look at some of these values, there's some values here. Yeah, when these are our intercepts, like I said, our x-intercept is -2 and the y is 0. Our y-intercept is 2 and the x is 0. But down here at 2, we get an error. It was an error. So why is that? Well, when I plug in 2 into my function here, I'm going to get 2 squared minus 4 on top and 2 minus 2 on bottom. That's 0 over 0. You can't divide by 0. You can never divide by 0. So we don't have a value here that makes that true. So when we're looking for the limit, we're looking for what we'd expect that value to be. We can do that a couple different ways. So I want to look at it graphically. Well, let's do numerically first. Okay. So I'm going to go back here. First of all, let's do this. So here's what we're trying to find. But look at this. Okay, so what we're trying to find here, we're trying to find the limit. If x equals 2, we get an error. Or f of x is an error. Okay. So what we're looking for the limit. Trouble here. Okay, so the limit of this function is written this way. LIM for limit. We want the limit as x approaches 2. This is the notation we write. The limit as x approaches 2 of our function. Or if you want, we can look at the limit as x approaches 2 of, well, let's just go ahead and plug this in. X squared minus 4 over x minus 2. Okay, so we want to know, if I'm looking for the limit, I'm looking for the expected value of what this would be. Well, a couple different ways we can do that. We know that at that value of 2, it is an error. We get 0 over 0. We can't divide by 0. So we can sneak up on it, though. So we're going to look at around 2. I'm going to make myself a little table here. Okay. A little table of values. That can be helpful. So we know when the x value is 2, there is no function value. But we can look for values around 2. So let's pick one. How about, I'm going to start over here. How about 1.9? That's close to 2. If I were to plug in 1.9, well, go back over here. I'm going to go back to my table. Now I could plug in 1.9 here. I could put this in my calculator. 1.9, square it, subtract 4, divided by, well, 1.9 minus 2 would be negative 0.1. Or, let the calculator do the work for me. I'm going to go back here to, not window, table set, second window. Quit. Second window. If I go to my second window, instead of having to be automatic here, I'm going to have the independent variable. I'm going to ask for the independent variable. In this case, x is the independent variable. So go over here to ask, press enter, go back to my table. I've already got this function value in here. So I'm going to go back to my table. And I want to know, well, when x is 1.9, what do I get for a y value? Well, I get 3.9. Okay. Well, I'm going to sneak up. I'm going to get even closer to 2. 1.99 is even closer to 2. Sorry. If I ask, put in 1.99. I get 3.99. Put that here. And then if I get even closer, how about 1.999? I get 3.999. See what's going on there? So as I get closer and closer and closer to 2 on the right, I'm getting closer and closer and closer to an expected value. What about on the left side? That is on the left side. Okay, scratch that. This is all going to go over here. I told you, be easy on me. I messed up. I'm going to cut this if I can. Okay. This should probably flip around. Sorry, 1.99. .9 and 1.99 and 3.99, 1.999 and 3.999. Okay. Sorry. Hope you get the idea. I just screwed that up. But give me a break. Okay. I'm sneaking up to 2 from the left side of 2. I'm getting closer and closer to 2 as x is getting larger. My y value, my f of x, is becoming closer and closer to a certain value. What about on the right side? On the right side, I might look at something close to 2, like 2.1, or 2.01, or 2.001. Let's go back to here. 2.1. I get 4.1. If I get closer to it, 2.01, 4.01, 2.001, 4.001. And I wouldn't have to stop there. I could get closer and closer and closer and closer. These values keep getting closer to 2 from the right. These values keep getting closer to 2 from the left. But as you can see, both of these are converging on a single value. Hope you can see it. This is getting closer and closer, both of these, to 4. So the limit of this function as x approaches 2 equals 4. It's the expected value. Now, if I want to look at that graphically, well, let's go back to the graph. It looks like this. If I press trace, well, there's x equals 0, y equals 2. We're approaching 2 on the x. So as I get closer and closer to 2, there's 1.27, 1.48, 1.7, 1.91. Okay. So in between 1.91 and 2.12, well, this is 4.12. This is 3.91. I'm expecting that to be 4. Now here's the key point to this, what you've got to make sure to remember. This function value, f of 2, does not exist. I can't have f of 2. When I plugged in 2 into here, I get 2 squared minus 4 over 2 minus 2. That's 0 over 0. Okay, can't have that. Now it's not a solution, so this is undefined. Okay, it's not equal either, but so f of 2 is undefined. The function value is not defined. The limit equals 4. These do not have to be the same. The limit as x approaches the value of the function does not have to be the same as the value at that function. It could be. It doesn't have to be. So if I'm looking at the graph of this function, basically it would look something like this. I got my x and y axis. Or just to sketch it, out here at 2, 1, 2, 3, 4. At this value here, 2, 4, well, that's where we would expect it to be, but since it's undefined, I'm just going to leave that open. And then it's going to set up as linear, so it comes down kind of like this. Your graphing calculator won't put a hole in there like that, but this is the way, if I were to graph it, it would look. Okay, so if you want to find a limit numerically, sneak up to it from both sides. If you want to find it graphically, look at what the graph tells you. We'll look at some other examples here in a second. Okay, next page. Sometimes limits do not exist, and there's 3 different cases when that can happen. When there's different behavior on the right and the left. It's when it's unbounded behavior and oscillating behavior. Pause that right there to write that down. That'd be a good idea. Okay. Take a look at this graph here. Lots of stuff going on. So, let's take a look at, let's just call this, for our sakes, g of x. So in this example, if I wanted to find the limit, let's say as x approaches -4 of g of x. Pause right there and see if you can figure out what that would be. As x approaches -4 over here, well, as I approach it, I'm approaching it from the left on this side, and it's coming down to right here. I'm approaching it from the right of -4 here, and I'm approaching there. Well, this expected y value would be 2. Now that's different than what the function actually is. This function at the x value -4 equals 0. There's a solid dot right there. It's defined at -4 to equal 0. But when we would expect it, as we look around it, it's going to be right there. Okay. Let's look at this example here. Number 1, different right and left behavior. Well, this is going to happen when I'm looking at the limit as x approaches 0. That's supposed to say LIM for limit. The limit as x approaches 0. Well, as I approach it from the left, here's 0. Here's 0 right here. That's my x value. Y-axis is x equals 0. As I'm approaching 0 from the left, the graph is coming up here. As I approach 0 from the left, I hit the axis, it's 0. But as I approach it from the right, I hit up here at 5. So, if I have different right and left behavior, if to the left and right of this x value here are different, I can't determine which one is more correct. I don't know if I'm looking for this value or if I'm looking for this value. So we just say DNE does not exist. And it's really that simple. We can write DNE. That is legal. That's fine. You write DNE, we know what you're talking about. Okay? So different left and right behavior doesn't exist. Unbounded behavior, well, that's going to look something like this. If it's unbounded, that's where it's either going to be going up to positive infinity or down to negative infinity. One example here that I look at is x is approaching -2. This also does not exist because as I approach -2 here, it's going down to a negative infinity. As I approach -2 here, it's also going down to negative infinity. Here's my -2. As I approach it from the left and right, these are both heading down. and E. Equals is, we say equals a number. We don't really say equals D and E, but we just say it does not exist. And lastly, oscillating behavior. Well, let me get you, let's look at the graph again. Let's go back here. Oops, turn it on. Y equals, let's look at something like this. The sine of 1 over x. Divided by x. Now let's look at the graph of that. Six. Okay, a little hard to see here. Let's zoom in. A whole bunch of stuff going on here. Zoom in again. See what's going on. I'm looking right around 0. We know 1 over 0 is going to be 0. Well, as this is approaching, I'm just going to press the trace button. I can go through and look at the table again at some values if I want to do this numerically, but I'm not going to do that. I'm going to go way out here to, okay. So at negative 3.45, I get a y value, expected y value of a negative 2.46. As I move closer to 0, again, what I'm looking for here, I'm looking at the limit as x approaching 0 of sine of 1 over x. As I move along here, as I get closer to 0, I got a negative y value, then it becomes a positive y value, even though I'm getting closer to 0. Notice the y value here as I'm getting closer and closer to 0. I keep moving to the right. And I go up to positive 1. And then it starts coming back down. And I go back down negative. And it's going down to negative 1. And the closer I get, it's hopping all over the place. It's going up, down, up, down. And now it's back up here to positive 1. Now it's back down here close to 0. Now it's down here at negative 6 point. I'm still haven't reached 0 yet from the left-hand side. So at 0, it's undefined. Same thing happens on the right side. You watch the y value here as you increase and decrease, and you can try this on your own. It's going up, down, all over the place. It oscillates. This does not exist because it's all oscillates. It's all over. Okay. So that's where limits fail to exist. So try that at home. Here's your assignment. Try some of those. We'll work on the rest of them in class. Sorry for the lengthy video. Try to make it shorter next time.